Frontier models are costing you money you don't need to spend. That's the take. And the research backs it up. Hugging Face published findings showing that specialized smaller models consistently outperform much larger general-purpose models on domain-specific tasks. Not sometimes, consistently. And if you've been defaulting to GPT-4 or Claude for every single workflow in your stack, this should stop you cold. Let's get into it. The core finding is straightforward. A fine-tuned, smaller model trained on domain-specific data will beat a frontier model on that domain's tasks. Better accuracy, lower latency, a fraction of the cost per token. This isn't surprising to researchers, but most operators building real products haven't internalized it yet. The default behavior is to grab the most powerful model available and point it at every problem. It feels safe. It feels like you're not leaving performance on the table, but you are leaving money on the table, a lot of it. Here's the first argument worth sitting with. Frontier models are generalists. That's their strength and their weakness. GPT-4, Claude Opus, Gemini Ultra, they're built to handle anything you throw at them. Legal questions, poetry, code, customer support, data extraction. They're remarkable precisely because they're broad. But broad is expensive, and broad introduces latency at scale. When your highest volume workflow is something narrow, like extracting fields from invoices, or classifying support tickets into categories, or summarizing medical notes in a specific format, you are massively over-provisioning. You're paying for capabilities you will never use on that task. A specialized model trained on invoice extraction doesn't need to know how to write a sonnet. It needs to be fast, accurate, and cheap on that one job. And the research shows it will outperform the generalist on exactly that job, because it was trained on exactly that distribution of data. Second argument, cost compounds at volume. This is where operators feel it most. Early in a build, you're running maybe a few hundred completions a day. The cost difference between a frontier model and a specialized smaller model feels trivial, so you stick with the frontier model. Then you scale. Volume goes to tens of thousands of completions per day. Suddenly your inference bill is a significant line item. You're locked into an architecture that made sense at low volume, but doesn't make sense at the volume you're actually operating at. The time to evaluate specialized models is before you scale, not after, because switching costs are real. Prompts change, evals change, integration logic changes. The operators who do this analysis early win on margin. The ones who don't end up doing emergency cost-cutting later, which is painful and disruptive. Chapter 2, third argument, and this is the one most people miss. Latency is a product decision, not just a cost decision. Specialized, smaller models are faster. Not marginally faster, significantly faster. When you're running inference at the edge of a user-facing workflow, the difference between 800 milliseconds and 200 milliseconds is the difference between a product that feels responsive and one that feels broken. Most operators think about model selection purely through the lens of accuracy and cost. They underweight latency as a user experience variable. But speed is a feature, and specialized models give you that feature almost for free. It's a determinant of. So what does this mean if you're building right now? The build decision needs to change. Stop starting with the question, which frontier model should I use? Start with the question, what are my highest volume workflows? And have I actually evaluated whether a specialized model beats frontier on those specific tasks? That second question requires work. You need to set up proper evals. You need to identify candidate models. You need to test them against your actual data distribution, not benchmarks. Benchmarks lie. Your data is the only ground truth that matters. For workflow automation specifically, this is where tools like Lindy become genuinely useful. Lindy runs agents end-to-end across multi-step workflows, and the way I'd use it here is to build a fast evaluation pipeline that routes tasks to different model backends so you can compare performance on your actual production data without rebuilding your entire stack. Full disclosure, I may earn a small commission from that link below. But the broader point stands regardless of what tooling you use. You need a model evaluation habit, not a model selection habit. Evaluation is ongoing. The model landscape is moving fast. A specialized model that beats Frontier today might be replaced by an even better fine-tune next quarter. To pair of change, here's the contrarian angle most commentators are missing. Everyone's framing this as small models versus big models. That's the wrong frame. The real insight is about procurement strategy. Right now, most operators procure AI models the same way enterprises used to procure software. Buy the biggest, most capable thing from the most reputable vendor and apply it everywhere. It feels safe. It's defensible to stakeholders. Nobody got fired for using GPT-4, but that logic is breaking down fast. The model landscape now has hundreds of specialized, high-quality options, open-source fine-tunes, domain-specific models for legal, medical, financial, code, small models distilled from large ones that retain most of the performance on narrow tasks. The operators who figure out model routing, meaning matching the right model to the right task at the right cost, will have a structural cost and performance advantage over competitors who don't. This isn't a temporary arbitrage, it's a competency. And building that competency now, while most competitors are still defaulting to Frontier, is a durable edge. The builders who treat model selection as a procurement and ops discipline rather than a one-time technical decision will win on margin. And in a world where AI is increasingly commoditized, margin is the moat. Today, before you go, the lazy default is Frontier models for everything. But the research is clear, and the math is clear. Specialized models beat generalists on narrow tasks, and narrow tasks are what most high-volume production workflows actually are. The question for you, what is your single highest volume AI workflow right now? And when did you last actually run an eval to see if a smaller, specialized model beats your current setup on that specific task?